These two graphs represent exponential growth and exponential decay. And the red one is the growth, because reading it from left to right, it is getting higher and higher, so it's growing. And the blue one is called exponential decay, or some kind of depreciation, or opposite of growing. So it is going down as you read it from left to right. It has a steep drop and then it kind of tapers off, but it's still constantly getting smaller and smaller and smaller as it goes to the right. An exponential function has this format, and assuming a is positive, then you have two ways you can tell whether it's growth or decay without ever having to graph it. You look at the base b, and if b is greater than 1, that means it's going to be growing. However, if b is small, and I don't mean negative, I mean between 0 and 1, so we're talking about things like fractions, like 1/3 or 2/5 or things like that, but not negative, just anything between 0 and 1, then you're talking decay. And that's only true if a is positive. If a is not positive, then we've got a different thing going on, but the very typical exponential growth and decay will have a being positive and will have b either being a number greater than 1 or a number between 0 and 1. Now x is the exponent, and that will determine how steep it is, but that is not going to determine whether it's growth or decay as long as x is positive. Actually, x can be positive or negative, as we saw in our table that we did in the previous video, but a has to be positive and b can be one of these two scenarios, greater than 1 or between 0 and 1. The other thing I want you to notice is where the y-intercept is. The y-intercept on both of these functions was at 0, 1. Now, it's not always going to be at 0, 1. It kind of depends. A will change that. And so the reason that both of these went through 0, 1 is because the a in both situations was assumed to be a 1. We just didn't write it there because it really had no effect on it if a is 1. But that is why it went through 0, 1. So if you change that a and make it 2 or 3 or 1/2 or anything, you can assume that the y-intercept will always be 0, a. And so this particular one, yes, it was at 0, 1, but that's because a was 1, and a will change in some of the next examples we do. But this is the formula for the y-intercept on exponential functions. So the question might be asked, look at this exponential function and say whether it's growth or decay and where its y-intercept is. And so on the first one, we can look at, first of all, a is positive, so that's good, and a is positive on the other one as well. So that meets the first qualification. The second thing is you look at what your b is, and your b is a number between 0 and 1, because 0.95 is between 0 and 1. Therefore, this must be exponential decay. The place where it crosses the y-axis will be 0, 12, because it's always 0, the a value. So if you can just visualize a quick sketch of this graph, it's going through the y-axis up at 12, 0, 12, and it's decaying, so it's going to be dropping really fast and then tapering off. On the second one, always first check to see if a is positive, then you can go by the b number to decide if this is exponential growth or decay. Because b is greater than 1, that means it's going to grow, and so this is a growth exponential function. So the graph of this would go through 0, 1/4 on the y-axis. That would be the y-intercept. And then let's sketch it. So it would go through the y-axis at 1/4, way down at the bottom there. And it's going to be growth, so it's going to start small and then shoot up from left to right. The last term I want you to know for exponential growth and decay is that the decay factor is your b when this is a decay function. So the 0.95 is the decay factor, and that, if you think about it, that's the number that's being multiplied times itself over and over and over again because it's being raised to a power, and raising to a power means multiply 0.95 times itself that many times. And so that's why it's called a factor, because it's the thing that's being multiplied over and over. And so it's called the decay factor when it's between 0 and 1, and the number is called the growth factor if it is greater than 1. And so 3 is the growth factor, 0.95 is the decay factor, and you'll need to know those words.